Hello, my name is Joshua Odmark. I'm the CTO and co-founder of Pandio. Today I'm going to demonstrate how to do ETL through datasets in PandioML. There's lots of different providers or ways to do ETL. I want to show another one here using datasets in PandioML. The benefit here is you have a lot more control over what you can do. Datasets in general handle the E or the extract and the load for you. So all you really need to worry about is the transform here in the dataset. There's platforms out there that you could use to do this as well. And then you could just use a dataset to connect that platform that does the ETL for you. So whatever that ETL tool is, the load part of that tool would be the data set. So that ETL tool would be read by this data set. But you can actually do the transforms right in this data set for a full ETL tool. And since it's very easy to run these on the Pandio platform, it makes a fantastic way of doing ETL. So what we have here in front of you is a data set that I built with PandioML. The premise of this one is it's trying to detect lead spam. So what this data set is doing is it's retrieving things like form submissions and then submissions that somebody manually typed in and form submissions that are submitted over like a web form. So three distinct sources of information, the same type of information, and then they're being sent into one sort of source of data. So that's a very interesting use case because web form data in general is not the highest of quality. So, typically that's when you have to do sort of a transform, is when the data can vary wildly and you don't necessarily know the quality. So when you retrieve that data source, you need to sort of look at the data and maybe correct things or null things out or just do any type of thing to make that data more predictable. So that's what we're going to address here today. So this data set is just using a local CSV file of this data just to make this demonstration straightforward. And all the traditional things are here. It sort of iterates through this data set and creates it into a schema. But I've added this function here, which is basically my transform. So this function is just going to read through all the data and sort of set it to what I need it to be. So a good example here is so there's a lot of this information here where it's either like a default fill of something, so it's actually string null versus the actual null value. Two very different things. Sometimes it's just a programmatic thing was entered as user. Sometimes, like, this is something that's a human manually types into fields. So that's kind of the point of this, is you never really know the type of data that's going to come through. But for me to do machine learning on it, I need to sort of remove these values and set them to an empty string. You could let them go through, but my sort of compute at the end of the day, because I need to sort of turn these into vectors, would be much higher having to do that. So just setting this to null, or empty string in this case, is going to save me a lot down the road when this data actually gets into my pipeline. Same type of a thing is happening here. So these are the only three values we're expecting. So if anything else is seen, then it should just be set to an empty string, because if I see anything besides those three values, somebody types something wrong, and so I just want to remove that. And so this second piece here, so this is pretty interesting. So sometimes with this data, someone enters first name, but they put their whole name in the first name field. So this is just addressing that situation where last name's empty, first name has values, and then there's a space in the first name. So this is pretty rudimentary. You'd want to sort of build out this logic to better parse first name into first name and last name. But this is just a sort of quick little sample that I'm giving you guys here. And it just uses the probable people library, which is very good at parsing a string that has different types of name attributes in it. And so that's really it. So what happens here is once this data set sort of cleans up the data a little bit, now this data can flow in a proper schema into my pipeline. Now, because I'm setting things to an empty string, this is very common. You don't always have all the data points. You'll see here in the function, in my feature extraction, I've got to handle these use cases where the string is empty. So what you're seeing here is, let's look at the first name. So I'm vectorizing the first name into 8 individual parameters based on this configured vectorizer up here. So I've set it to 8 features. So when I don't have a first name, I don't want to bother vectorizing that. So I want, because that's not a cheap thing to do right here. This is not a cheap method to call. So I can easily just set it and zero it out and pass in the 8 zeros basically. And so that's what I'm doing throughout this, is I'm just, when I don't have that value, so it's an empty string, I'm just setting it to something default. So you'll see that in various places throughout this, and that's how I'm achieving that. That's very important because we need to maintain the dimensions that the features are pulling out. So that array needs to be the same number of entries every time. Otherwise, it's going to blow up your model. It's very difficult to sort of troubleshoot and figure some of those things out. So that's the importance of making sure your data is of a certain format, and more importantly, that your features always build an array of the same type. You could even do a check here at the end to make sure that you have enough entries in your data array. But that doesn't always mean that things are correct, because you have to be careful how these things are actually added. So this is just an array of numbers at the end of the day, this data field. So if I add 8 here, and the next time I'm supposed to add 8 as well, but my if statements or things are such situated that I append maybe only 1 0, so that means my features are out of order, and that's very dangerous. Can cause massive problems. You want to definitely make sure your features are always added in the same order. So that's why you see them here all handled explicitly together. So email is taken care of all together. Last name is taken care of all together. Email here, as I'm creating new features out of this, so that's handled all together as well. So you want to be very careful embedding if statements, because that can lead to generating features out of order, which again is really bad. So that's really it for this demonstration. I just wanted to show that you can use datasets to do ETL, and you really can put any Python code you want here. I imported this probable people library here, so a very powerful open source library to do some of this for me. You can import anything else. You could do a query into another database to join data. This is just Python code that's ran for you at the end of the day, so it can do anything. Just be cognizant not to, if you're going to build something that does an ETL that requires a lot of resources, you want to make sure that if you deploy this data set on the Pandio platform, that you allocate enough resources to do that. One example might be if you want to add in machine learning into your data set to do address parsing. So there's lots of popular models out there that can parse mailing addresses very accurately. Some are very heavyweight, so they require 4 gigs of memory to run. So if you use a library like that, I just want to make sure when you deploy this function to the Pandio platform that you allocate enough memory. That's really it for this demonstration. Thank you for watching, and and look for other demonstrations for PandioML coming soon. Thank you.